Hello, today I'd like to show you a tool that I like to use called OpenSpeedTest. And so what OpenSpeedTest can do for you is it can show you the speed of the devices in your network without having to do a speed test out to the internet. So you can go from, if you load this speed test app onto a computer, then you can measure it internally. So let me show you what I'm talking about. You could go to this site, OpenSpeedTest.com, and download it, and then you can put it on any computer, or you can even put it on a phone. But what I want to show you here today is here is our Unify system, and we're looking at the network app. And so on the guest room U7, I've got a U7 access point, and you can see here that it's broadcasting in, let me make this a little bit bigger. You can see that it's broadcasting in Wi-Fi 7 capability on channel 48 in 5 gigahertz and on channel 85, 160 megahertz channel on in 6 gigahertz. And I'm not broadcasting in 2.4, so I disabled it. And I have 3 clients that are connected, right? I've got my phone, I've got another laptop, and then a PC. And so let's take a look at the 3 different devices, and we'll see what their capabilities are. So now if I look at my Apple iPhone, it's connected and it's got a strong signal. It says neg 60. Its standard is Wi-Fi 7, and you can see from this that it connected in 6 gigahertz on a 160 megahertz wide channel. Okay, so we should be able to get pretty good throughput speed to the iPhone, right? And it says that the receive rate is 1.73 and the transmit rate is different. We could talk about what makes that different, but basically when the phone is talking to the access point has more spatial streams, and so it might it might choose more spatial streams to communicate with, which could give it higher throughput. Well, kind of. It can guarantee that the two are a stronger modulation coding scheme is probably the best way to say it. But MCS rates can differ between the access point transmitting and the client device transmitting. So a lot of times you'll see a difference between RX rate and TX rate. It's due to MCS codes, and we'll have to dig deeper into it if we want to explain it better. All right, so then the other two, let's look at the other two. Let's see, can I go back? I'll close this out. I guess I got to come back into it, and we'll look at the Lenovo. So the Lenovo is connected at neg 35, so a lot stronger signal. It's connected to a 5 gigahertz, 80 megahertz wide channel. So I don't like 80 megahertz wide in 5 gigahertz, but for this test, we'll assume it's okay. MIMO configuration 2x2, and you can see here there's a little bit of difference here in the transmit and receive rate too. Okay, so I'm going to run the server on this Lenovo, and I'm also going to run it on the other device. So let's look at the other device that is the third device, and it's this device here. And so look at this. So this is neg 51. So it's sitting right beside the access point. Both of them are, but it's in 5 gigahertz. And what else do we see? This Wi-Fi standard is Wi-Fi 5. So Wi-Fi 5 802.11 AC. So, and you can see that the receive rate and transmit rate are the same, but it is a Wi-Fi 5 connection, so 867 is as much as we can get with that. So let's take a look at what the speed test looks like. I ran a speed test earlier on it, and here's the one from the Lenovo, and you could see there was a difference in receive and transmit capability, and you can see that the download was 534.5 and upload was 994, and then that is for the faster of the two devices. Then the Wi-Fi, this is Wi-Fi 6, the Wi-Fi 5 device, look at that, 142. And upload is 383, so something changed during it to make it different. It looked like it was 867 on the 5 for both of them, but you can see the actual download and upload speeds for the devices are much slower. Now, again, this is from the device to this computer. And this computer, if we looked at it, it's hardwired in. So if we look at client devices, the computer that I'm doing this broadcast from is this one. All right, so it's a Ethernet connection, And the reason I did it that way is because I didn't want it to also affect the throughput, because if this one's on the network on a Wi-Fi connection, then again, it's going to be sharing airtime with the other devices. So we just had those other devices on. Okay, one last thing that you can do with it is you could host it on your website. So let's say you're not too excited about the speed test that you get from Ubiquiti. Let's take a look at this. So here, if I go to the main dashboard, you can see that this is going to go to the internet's going to go to Ori Telephone Corporate. It's going to go to their server, right? So if I, or sorry, it's going to go to a Ubiquiti server. I'm not sure which one it's going to go to, but if I do, let's look. If I go do a speed test, it connects. It goes to a specific server provider. There you go, Skyrunner Inc. To United States. And so you can see that it's going to that one, and it's getting 528 there and 349. But some ISPs have a much faster throughput. They might have a 10 gig throughput, and so it might not show up on the server that they're running. So you can host this on your own site. So here I have this set up on mine, and you could do OpenSpeedTest, and I could do a speed test to it from this computer. And so let's just do it. And so it's going to run out to my website. And so you can see that it's going to get, I think I have with my service, I have a 500 megabit per second throughput cap on mine. And so it's going to get 375.5. Okay. And it looks like it's going to do about the same with the upload. Anyhow, you can host this on your site. This is a better way. So if you've guaranteed like 10 gigs for a client and they're trying to do a speed test to the servers that are on the Ubiquiti website, or that are part of that Ubiquiti system, and they're doing speed tests and they're like, hey, I'm not getting what I'm paying for, you could host this OpenSpeedTest on your server, and then they could go directly to your server. So a cool tool. All right, that's it. Thank you.